All right, so there are two types of sequences that we work with. The first being the arithmetic sequence, most popularly known from Algebra 1 and pre-algebra as linear equations, which are a perfect example of arithmetic sequences. And what these are we have pairs of successive numbers that have a common difference. That means that I'm adding a constant to each term to get the next term. Um, Explicitly, our equation is in the form of I can find any nth term by taking the first term, a1, plus n minus 1 times d, which is what we call the common difference, that number that we're adding every time. Uh, Recursively, I do have to be given a term. Typically, we are given the first term. And then to find each successive term, we just add d to the previous term. So kind of an example of how this works is I have a couple of sequences here. And when dealing with arithmetic sequences, the key here is we have to know d and we have to know the first term. So to figure out d, I just pick two terms that are next to each other and subtract the later one from the first one. I usually just go with the first two. So if I do -2 minus -5, I get +3. And if I check, if I add 3 to each term, yep, that works. So that means that my common difference is 3. So then, since I know my first term, so then now that I know d, a recursive rule would be my nth term would be the previous term plus 3. If I wanted to do this explicitly, well, then explicitly, it would be my first term, which I'm told is -5, plus n minus 1 times 3. And so then if I wanted to find the ninth term, a9 would be -5 plus 8 times 3. Well, 8 times 3 is 24, plus a -5 is 19. This also works then if I work with more non-traditional constants in these, such as natural logs. So here, if I have natural log of 2, natural log of 6, natural log of 18, natural log of 54, again, the first thing I need is my common difference. So if I look at the natural log, sorry, if I were to look at the natural log of 6 minus the natural log of 2, well, using a property of logarithms, this is the same as the natural log of 6 divided by 2, which would be the natural log of 3. And that does work for each term. Because if I do the natural log of 6 plus natural log of 3, another property of logarithms says that would be the natural log of 6 times 3, which is the natural log of 18. So now that I know that, recursively, each term is the previous term plus the natural log of 3. Explicitly, each term would be my first term, natural log of 2, plus n minus 1 times the natural log of 3. And so then, if I wanted to find the ninth term, this would be the natural log of 2 plus 9 minus 1, which is 8, times the natural log of 3. Uh, and I could combine all of those into one logarithm, which would be the natural log of 2 times 3 to the 8th, and type it all in my calculator to find out what that is. So that's pretty much it for arithmetic sequences. For geometric sequences, uh, these are pairs of successive numbers that have a common quotient, uh, also sometimes called a common ratio. So this time, instead of adding the same thing each time, we're multiplying by it. Uh, these classic example is exponential. Exponential functions are most definitely geometric sequences. And so, again, we can write this explicitly or recursively. Explicitly, each term would be the first term times my common quotient or common ratio raised to the n minus first power. Recursively, each term is the previous term times my common ratio. So again, doing similar problems to this, just like with arithmetic, I needed to find common difference. The key to geometric is knowing my common ratio and knowing my first term. So to find my common ratio, instead of taking second term minus the first, I'm going to take the second term divided by the first, which would be negative 2. And I can check to see then, well, 1 times negative 2 is negative 2. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. And so that does work. So then, recursively, each term would be the previous term times negative 2. Or if I wanted to do this explicitly, that would be my first term, which is 1, times negative 2 to the n minus first power. And the negative 2 does have to be in parentheses here, because I'm raising all of negative 2 to that power, not just the 2. And so then my ninth term would be 1 times negative 2 to the 8th. And negative 2 to the 8th is the same as 4 to the 4th, so that would be 256. Working with a different example here, if I want to find my common ratio, well, 10 to the negative first over 10 to the negative second is 10, and checking that, that does work each time. So then recursively, each term is the previous term times 10. Explicitly, each term is the first term, 10 to the negative second, times 10 to the n minus 1. So then my ninth term would be 10 to the negative second times 10 to the 8th, which would be 10 to the 6th, or 1 million. Final example here is what if we aren't given the first term, especially for geometric. I will say arithmetic we don't use very much in calculus because they are just linear equations. We tend to use a lot of geometric, especially when we start working with more advanced trig functions and switching them into series. We tend to go with geometric ones. So here, if we have given a second term of the geometric sequence is 6, and the fifth term is negative 48, we want to find the first term, the common ratio, and an explicit rule to find the nth term. Well, my explicit rule gets written this way. And what I can do then is I can set up a system. If I plug in my second term, well, A2 is A1 times whatever my common ratio is, times 2 minus 1, which is 1, and I know that equals 6. Then A5 is my A1 times r to the 4th, which I know is negative 48. So typically, I'm going to go ahead and take this and solve it for r. So r is equal to 6 over, I'm sorry, not for r. I think I'm going to solve it for a1. So a1 is 6 over r. And I'm going to substitute it into here. So 6 over r times r to the 4th equals negative 48. So that means 6r to the 3rd equals negative 48. R to the 3rd is, let's see, negative 8. So r would be negative 2. So I now know my common ratio. Well, now that I know my common ratio, I can use that to find my a1. So my first term is 6 divided by negative 2, which is negative 3. So my explicit rule would be that each term is my first term times my common ratio to the n minus first power.